Hello everyone, welcome to the video lecture series on Advanced Separation Process. Myself, Jamin Pandya, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. So let's continue with the chapter number 2, which is a membrane separation process. So in this lecture, we are going to discuss about various parameters affecting on performance of nanofiltration. Then we'll discuss about the various industrial application of the nanofiltration and process limitation for the nanofiltration. So let's discuss about the first parameter affecting the performance of nanofiltration. While designing nanofiltration process, one should consider various operating parameters. The most important parameter affecting the performance of nanofiltration are similar to those for most cross-flow filtration process. So let's discuss about briefly about this parameter. So there are mainly four parameters which affect on nanofiltration process, such as pressure, temperature, cross flow velocity and solution pH. So let's first discuss about pressure. Pressure difference is a driving force responsible for the nanofiltration. The effective driving pressure is a applied hydraulic pressure less than the osmotic pressure applied on membrane by the solute. Nanofiltration provide good separation at net pressure range of 150 psi, or can say that 10 bar or higher of that. If we will increase the pressure, we will get higher flux in nanofiltration process. Now let's discuss about second parameter, which is the temperature. Increase the process temperature, increase the nanofiltration flux due to the reduction in viscosity. However, the rejection of nanofiltration membrane is not depend significantly on process temperature, because it's work on the Donner exclusion and size exclusion theory also. Now let's discuss about third parameter, which is the cross flow velocity. Increase in cross flow velocity in nanofiltration membrane process increase the average flux due to the efficient removal of fouling layer from the membrane surface. However, the mechanical strength of the membrane and construction of the element and system hardware will be determine maximum cross flow velocity that can be applied. Running nanofiltration membrane at too high cross flow velocity may cause a premature failure of membrane and module. So, it is necessary to operate nanofiltration plant at optimum cross flow velocity. Now let's discuss about next parameter, which is a solution pH. pH affects performance of nanofiltration membrane in more than one way. The charge site on nanofiltration membrane surface are negatively charged at neutral pH or higher. It is well known that the most nanofiltration and reverse osmosis membrane have a lower rejection at low pH. It should be not that, however, that since different membrane manufacturers use different chemistry for produce their thin film composite layer, the pH dependency of membrane should be determined for each membrane type. So it depends on charge of surface layer of the membrane. In addition to affect the pH on membrane itself, pH can be responsible for change in feed solution causing the change in membrane performance. For example, change of solubility, ions at different pH causing the different rejection rate, and change in deassociation state of ions at different pH range. If we are going to increase the pressure, flux of nanofiltration will also increase, but if we are running nanofiltration plant at higher pressure, there is a chance of failure of the membrane. Second parameter, which is the temperature. If we are going to increase the temperature, density of the solute is decreased so that flux of nanofiltration plant is increased. But temperature does not majorly affect on nanofiltration performance. Then cross flow velocity. If we are going to increase the cross flow velocity, we will also increase the flux of nanofiltration, but there is also chance for failure of the nanofiltration membrane due to the high cross velocity. If we are going to increase the cross flow velocity, the fouling and concentration polarization is decreased so that flux of nanofiltration will increase. The major effect parameter on nanofiltration membrane is solution pH, or consider pH of the solution. So if pH of solution is very low, it might be effect on surface of nanofiltration membrane, which is a reason of separation of charged solute. So if we are going to use lower pH and maximum higher pH, then it will be effect on surface of membrane of nanofiltration membrane, and we cannot get separation of charged solute, which make nanofiltration too unique than other membrane separation process. So this is all about the various parameters which affect on performance of nanofiltration. Now let us discuss about various industrial application for the nanofiltration. Application of nanofiltration membrane have grown significantly of their operation expanded. Well, beyond its roots as a loose arrow, nanofiltration is now integral step in many separation processes such as seawater desalination, dairy industry, sugar industry, textile industry, metallurgical industry, and landfill and agriculture. So let's first discuss about seawater desalination. One of the major problems to efficiently desalting seawater is the tendency for the reverse osmosis membrane to become foul with salt and organic material. UF can remove this constraint before the water reach the RO membrane, reducing fouling and increase in efficiency. Nanofiltration is used for the soften water and clean up streamware, completely removal of mono ions and either unacceptable or undesirable ions. So this figure shows nanofiltration for the desalination of seawater, where first forward osmosis module are used to purify the water, where draw solution are used to purify the water. To separate the draw solution plus water, we can use the nanofiltration process. We can also use reverse osmosis for same process, but if we are going to use reverse osmosis, we have to apply higher pressure, which result in higher energy consumption. So we can replace this reverse osmosis using the nanofiltration, where energy requirement and pressure requirement is low, and nanofiltration can effectively removal of monovalent and partially removal of charged solute due to unique characteristic of nanofiltration membrane. So this is how the nanofiltration used for the seawater desalination. Now let's discuss about the how the nanofiltration used for the dairy industry. In dairy industry, nanofiltration used for the production of whey, which is a byproduct of protein. If we are going to use evaporation for the production of whey, we have to do electrodialysis for further process, and we will get 20% whey and 60% demineralized. Where if we are directly going to use the nanofiltration process instead of the evaporation, we will get the 20% whey and 40% demineralized. So this is how the nanofiltration used in dairy industry. Now let us discuss about the next application, which is in sugar industry. So in sugar industry, nanofiltration used for the concentrate of the sugar, where traditional concentration process such as evaporation is not effective. There the nanofiltration are used. So in sugar industry, nanofiltration used for the concentration of sugar. Then nanofiltration is also used in textile industry to concentration of dye and removal of the pure water. Then it's also used in metallurgical application, where it's used for the removing heavy metals from the wastewater. So it's also used for the removing heavy metals from the wastewater, and we will get precious heavy metal, and again we can reuse it and get pure water from the nanofiltration as a permeate. Then it's also used for the landfills and agriculture process. So this is a various industrial application for nanofiltration membrane. Now let us discuss about various process limitation for the nanofiltration membrane. So there are various limitations for the nanofiltration membrane separation process, such as osmotic pressure, membrane chemistry, concentration polarization, rejection, clogging, and fouling. So let's first discuss about the osmotic pressure. osmotic pressure is a critical design consideration. Osmotic pressure is always calculated for the bulk feed stream. It is a change along the membrane train as the salt concentration rise. The osmotic pressure that really matter is one that membrane higher by the amount polarization rise by the concentration of the solute. Second parameter, which is a membrane chemistry. Three chemical groups dominate the nanofiltration membrane industry: cellulose ester, aromatic polyamide, and cross-linked polyamide. Both cellulose ester and amines have a poor resistance to chlorine. Chlorine can be oxidized cellulose acetate membrane, result in opening up the pores. On other hand, the intermolecular hydrogen bond get disturbed due to the electrophilic substitution of aromatic ring by the chlorine. However, aromatic polymers have a higher pH tolerance than cellulose acetate. Cross-linked polyamide are better candidates for the nanofiltration membrane because of their higher permeability. So, from these three groups, cross-linked polymers are much better than cellulose acetate and polyamides. Then for second number, it's come for the polyamides, and for third, it's come to a cellulose acetate. Then third parameter, which is a concentration polarization, which affect on most of the membrane separation process. It is a function of both flux with increased mass rate of the material across the membrane and cross flow velocity, which reduce the polarization by enhancing feed side mass transfer. Through it is a far less problem in nanofiltration than its ultrafiltration and microfiltration. Now let's discuss about fourth important limitation for the nanofiltration membrane separation process, which is a rejection. The highest rejection membrane are those designed for the single pass production of potable water from the sea. The generally acceptable criteria is 99.4% rejection of NaCl. Now let us discuss about the next parameter, which is plugging. The silt carried into the membrane module may be deposit and plug it. Membrane configuration in their ability to tolerate suspended solid, with the hollow fiber fed cell and side being the least tolerance and large pore tube fed tube side being the most tolerant. Membrane manufacturers use as a silt density index to show the tolerance of the suspended solid. And next parameter, which is the fouling. All membranes are subject to fouling. Prevention and remediation of fouling are major economical and operating concerns in design of membrane facility. Scaling results from the precipitation of solute, the colloid deposit on membrane. In split off, cross flow and biofouling is a problem for most of the feed. So this is all our various parameters for limitation of nanofiltration membrane and how affect in nanofiltration membrane separation process. So in this lecture, discuss about the various parameters which affect on the nanofiltration and discuss about the various process limitation. So this is all about today's lecture. I am completing my lecture here. Thank you.